Hey everyone, Mr. K here with the final part of our Hello World project. Last we left, we had a little game, or kind of a game, that has randomly spawning cubes, and they spawn inside the unit sphere, so they're not on top of each other. They have a random color, they have a name attached to it, and the last thing we need to do is deal with this ever-growing list of cubes, okay? And the idea is just to give you an idea of how you can deal with deleting things from the game, because you will be creating things, and well, if it gets to be too many, you can see the performance here. It's dropping. It was at 300 before, maybe even higher, but it is tanking slowly but surely. So we need to deal with all of that garbage down there, okay? So the idea is, and to add a little bit of flavor to it, we're going to shrink the cubes down into practically nothing, and when they get down to be too small, then we will remove them from the game. Okay, so first and foremost, we need something to keep track of all of our cubes. Okay, a good thing in reality to use to keep track of things is a list. So we're going to do the exact same thing here. Private. Now, I don't think I talked about this last video, but this private thing that I'm going to attempt to talk about and type at the same time basically just hides this from the inspector. All right, public, the cube prefab, shows up here, cube prefab, but these other ones don't because they're set to private. We're going to add another public one in there so you can actually see it. Anyway, cube list equals new list game object. Whoa. Okay, so we have made a list. What is all this? So similar to above, it's basically a variable, at least this first part right here. Okay, this is a variable called cube prefab, and it stores a game object. This is a variable called cube number, and it stores an integer. This is essentially a variable called cube list, and what it has is I shouldn't say store. What it references is a list of game objects. I say references for a reason. You don't really need to worry about it. Basically, it's just the name of a list of game objects. Okay. Over here, again, something we don't need to really worry about too much, but lists are a little bit different than integers in that we actually have to create them. So once we have this left side here is for declaring what the reference or what the name of the list is going to be, and the right side is for actually making the list. So this creates a list, kind of like we did that down here. All right, we made a color. All right, we called the name of the color C, and then we actually we made a name for the color, and then we made the color itself. Okay, same idea. All right, so now that we have a list, it is ready and willing to accept our cubes. What we're going to do is add our cubes. So cube list dot add, and then cube object. Okay, so after we've done everything we did to the cubes, we are now going to add it to our list of cubes. All right. From there, it is time to start thinking about shrinking these things down. Now, we need to basically come up with a scale factor. So we're going to call it exactly that. Public float scale factor equals 0.95f. Float f. What is all this? Basically, it just means decimal. All right. In computer terms, computer science, decimal numbers are called floating point numbers, and that's where the float comes from. The f is here because, well, floating point number is, oddly enough, or float is not the default type of decimal number in programming. That goes to the type double, which means double precision, which means really, really accurate. We don't need that kind of accuracy because we're not doing anything really heavy duty. We're just scaling cubes. So we're just going to stick with a float, and we have to put the F there so the compiler knows that this is really a float and not something else. Okay, just being specific. That's all there really is. Okay, so again, this is a public. So if I save this and flip back the inspector, we will see it pop up here. Okay, there's our scale factor, and we can adjust it as we need to. By the way, you can, since this is a number, you can drag this. And there's also a way to do a slider, but I don't remember how to do it off the top of my head, so ignore that. All right, so we now have a scale factor set up and declared. It's going to be 95% of the original, not the original, 95% of the previous frame's size. So when it starts out at size 1, frame 2, it's 95%, frame 3, it's 95% of 95%, and then so on and so forth. So how are we going to do that? Well, what we need to do is work our way through our list. And we're going to do that with a loop. So let me get this done first. Element in cube list. Okay, so this is a loop. A loop does exactly what it sounds like. It loops. Okay. This is a for each loop. There's a bunch of other different types. But this one is pretty much designed specifically to go through lists. Basically reads like this. For each cube element in the cube list. Okay, cube element is basically just a temporary variable. It's only going to exist inside the loop, and the idea is that it's going to take a look at every single cube in the cube list. Okay, now computer can only do really one thing at a time, so it's going to look at each cube individually, and this is the name that we're going to give to our current cube. All right, no matter which cube it is, whether it's the first one, the 5th one, or the 400th one, it's going to be called cube element. Okay, so that's how we're going to reference it. So let's do that. Let's reference it. Let's look at the cube element, and let's take a look at its scale. So transform and local scale. Now this is a lot similar to what we have up here for changing its spawn position. We adjusted its position, which is part of the transform component, which was part of the object itself. But we can't just call scale. It's got to be local scale. There's reasons behind it. I don't remember exactly what they were. Something to do with global scale versus local scale. Basically, you can't even put in scale. It exists. Okay, you can put in rotation, you can put in position, but you can't put in scale. I don't know. So anyway, local scale it is, and what we're going to do that local scale is we're going to multiply it by our scale, factor. Okay, and if I save this now, it will run as is, though it's not going to do the last part that we want. It'll just do the shrinking. All right, there they are. They are shrinking, but we still have an ever-growing list of cubes because despite the fact that they are shrinking down to nothing, there's still a lot of them there. In fact, the performance is still tanking because, in fact, it's tanking quicker than it was before. It's just they're still there, and the computer still has to calculate their position despite the fact they practically don't exist. They never actually hit 0. That's just 95% of 95% of 95%. So it gets really close to 0, but never actually quite gets there. Okay, so let's do the removing thing first, or next. All right, so now what we're going to do is a if statement. So if cube element dot transform dot local scale dot x is less than, and again I'm going to explain this afterwards. Okay, what is this? So an if, and this is pretty much the last big piece of programming that we haven't touched on yet, is an if statement. It's called a conditional. It basically checks to see if something is true, and if it is true, it will execute a block of code. And they get a little bit more complicated than that. You can do else's, which means, okay, if it's not true, then do this instead. And pretty nifty stuff, and you'll see them a lot. But in this case, the way it reads is basically if the x scale of the cube element is less than 0.1, then do whatever's inside these braces, okay? Again, we got to use local scale. I chose X because, well, we don't need to look at all 3 sizes. We just need to really look at one of them. And as soon as one of them is too small, then whatever, it's gone. Okay, I just chose X. Could have been Y, could have been Z, doesn't really matter. So what do we want to happen? What we want to do is destroy the cube because we're done with it. We want it gone. It's out of here. Okay, so this in theory should work, but it's not going to. I'm going to run the game. I'm going to get errors, 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 errors. The same error all over again, or every time, but it's a lot of errors, okay? Pause this. The object of type game object has been destroyed, but you're still trying to access it. Your script should either check if it's null or should not destroy the object. Okay, so basically what's happening is we're trying to access an element that is not there, okay? For whatever reason, it's going through this list, okay? Once this element gets destroyed, for some reason the list is looking at it again and it can't find it, and it doesn't know what's going on. Basically, what this does is it creates the current cube element gets pointed to something called null, which is like, it's not even zero, it's a reference that means it doesn't exist. It's like not a number, it is undefined, that kind of thing. All right, so in order to, the easy way to fix this is just to do one big check for something. All right, and what we're going to do is just check to see if the current element, the cube element, current item in the list, as long as it's not null, okay, which means this is actually, if what we're looking at is a valid object, then go ahead and do this, okay? If it's not a valid object, then, well, it won't happen and we'll just skip it. We'll pass over it, okay? So, this will fix our issue. So I can stop this. Should have stopped it before. Is it going to stop? Oh, God, what did I do? Oh, it was paused. All right. Save just in case I screwed it up. Let's take a look. And there we go. We have our shrinking cubes, and they are shrinking into existence. How do I know? Well, because this list of cubes is not growing. The numbers are always changing because we're getting more and more cubes, but the old ones are shrinking so small that they are hitting our if statement and just being destroyed outright. So, that is that. At this point, you have played with all of the major building blocks of programming, and basically this has been kind of like a crash course in just the basics, okay? You have dealt with your variables, you have dealt with conditionals, you've dealt with loops and lists, and you've played around with methods a little bit, things that did things. So you played around with the update method, the start method, the get component. You've got at this point at least the basic, hopefully a basic understanding of what to do in order to get your game to do some, basically what you want it to do. Okay, there is obviously a ton to go from here, but as far as programming tools go, this is it. All right, there are a couple other things beyond this, but you can accomplish a lot just with those 3 or 4 things right there. So thanks for watching. There will be more videos coming, but at this point we're going to take a little bit of break, and we'll come back in a little while. All right, bye.